Okay, first question. What's a prime number? So this is an exercise involving prime numbers. A prime number is a positive integer that is greater than 1 and for whom the only divisors of that integer are 1 and the number itself. So nothing else divides the number evenly besides 1 and the number itself. So I know that's a weird, you might have seen that definition before. Let's try on this list of numbers figuring out which ones are prime. Okay, so 2. The only the two integers I can think of that divide the number 2 evenly are the number 1 and the number 2. So 2 is a prime number. Same with the number 3. There's no number less than 3 besides 1 and 3 that divides 3 evenly. 4 is not a prime number because it's divisible by 2. 5 is a prime number because neither 2, 3, or 4 divide 5. 6 is not a prime number because 2 divides 6 and 3 divides 6. 7 is prime. 8 is not. It's divisible by 2. 9 is divisible by 3. 10 is divisible by 5 and 2. 11 is a prime number. 12 is divisible by 6 and by 2 and by 3 and by 4. Okay, so not a prime number. 13 is a prime number. 14 is divisible by 7 and 2. 15 is divisible by 5 and 3. 16 is divisible by 4. 17 is prime, not 18. And 19 is prime. So the idea is if the only things that divide the number are 1 and the number itself, then it's a prime number. So how do we test if a number is prime? Well, how about this? This is a good sort of midterm or exam strength question, although I can't give it now because I'm doing a video about it. Although if I do give it, feel free to come back to the video and copy down the answer. So what I'm doing here is, the question is, here's a value, n, is this number prime? And the way I'm going to test that is I will try every number between 2 and n minus 1, and I will just ask the question, is n divisible by I? And if the answer is yes, then clearly it wasn't prime. If I find the divisor of it, then it wasn't prime. So an example, let's look at 6. So is 6 prime? Well, let's try every number between 2 and 5. Okay, does 2 divide 6? Yes. Okay, so 6 isn't prime. We're done. Okay, how about the number, let's try 9. Okay, is the number 9 prime? Let's try every number between 2 and 8. Does 2 divide 9? No. Okay, keep going. Does 3 divide 9? Yes. Okay, 9's not prime. So immediately, if we find the divisor, 9 isn't prime. Okay, what about, let's try 11. Is 11 prime? Let's try, is it divisible by 2? Nope. 3? Nope. Is it divisible by 4? Nope. 5? Nope. 6? Nope. 7? Nope. 8? Nope. 9? Nope. 10? No. Okay, it isn't. So none of these things divide 11. That means 11 is prime. So that's all this loop is doing. Now, fortunately for us, I've written a function that contains the loop, so all we have to think about is this function is prime, which returns 0 if the number is not prime and 1 if the number is prime. Okay, great. So what's the point of the exercise? The point of the exercise is to handle this situation. In main, I want to call this function that returns an array of the number of primes up to a specific value. So in this case, if I give the number 50, I'm not saying give me the first 50 prime numbers. I'm saying give me every prime number that is less than or equal to 50. Okay, so the problem with this is inside of main, if I say give me all the prime numbers less than 50, how many of them are there? I mean, seriously, you might notice on this list, it's not really obvious. And it turns out that there's a lot of weird number theory stuff happening behind the scenes. It isn't generally possible to know exactly how many primes there are less than a particular value. Come to the office hours, we can talk about that. There are famous unsolved problems regarding that question. So main doesn't necessarily know how many primes it will get back. So it can't really hand over an array and say, here's an array, fill it up with data, because it doesn't know how many spaces that array needs. This function that computes the number of primes up to 50 is the only function that would be able to determine that, unless main does the computation itself. So here's my function. And we'll notice it's got a big problem. So you give me a value k, and I will look at every number between 2 and k and just ask the question, is it a prime number? Okay, and if it is a prime number, then I'll add 1 to my count. And the reason why this is helpful is I'll need to store all of those prime numbers in an array. So what I'm going to do first is count the number of prime numbers that I'm going to end up with. And then I will create an array of that size, and then I will fill it up with all of the prime numbers. I will just loop through and fill it up. And then I will return the array. Okay, so that's not going to work. We know already, yes, I get it. We have to create the array inside the function. There's no way that main would know how big to make the array. So the function needs to create the array. but it can't return an array that it created. So I wonder if we have a solution to this. And then just one more note. Main will need to know how big the array is. So what we'll do is main will pass in a pointer to an int, and I'll use that to tell main how big the array is. I'll set this pointer, the result, what the pointer points to. So for example, I make an int called size, and I give the function a pointer to my variable size. It will then set my variable size to equal the number of things in the array that it created. So what's our problem here? We need to create an array inside the function that can be returned. Well, we can't create a local variable because that would be destroyed when the function ends. But we can use malloc. So instead of creating my array in the scope of the function, I use malloc to allocate the array manually. Okay, how big do I want it to be? Well, I know how many primes I'm going to create, so num primes times the size of each element. Size of int. All right, so I call malloc to create my array, and then down here, I can return this if I want, because the array that I created is outside of any scope. It's manually allocated, so I can return it. I should make a note to myself that obviously if I call malloc, I need to eventually call the free function to make sure that storage gets reclaimed. But we're going to try running this the way it currently is written. It's just by using malloc to allocate the array. Here's the list of primes less than 50. 2, 3, 5, 7, 11, 13, 17, 19. Okay, that's the list I have here. And then I guess these ones too. I mean, you can go check this yourself, but I'll bet that they're correct. So I've done what I need. I've returned an array. So now main at this point is receiving a brand new, it's a pointer to a brand new array created by the function. It's also getting information about how big the array is via this size variable. And that's where it's using that in the loop. But I have to remember that when I'm done with that storage, I have to free it. Even if it's in a different scope, I need to make sure that before the last pointer to the storage is lost, that I free that space. So I'm going to call the free function here. One experiment you can try on your own is, what happens if you call the free function on storage you didn't get from malloc? You just pass in some arbitrary pointer. It hopefully won't surprise you that you will get a horrifying error and the program will crash. Free is only meant to be used as the inverse of malloc, only on something that malloc returned to you at some point earlier in the program. And moreover, once you've called free, you're not supposed to ever use that pointer again. So once I've called free on this array, it's done. I should not try and use it. I should not try and free it ever again. So here's an example of a case where it's true that obviously main could pass in an array to fill up with data, but here main doesn't know how big the array is supposed to be. The function is going to compute that information. And so we're stuck in a bit of we've got a chicken and egg problem that we can only solve by allocating the array inside the function. And to do that, we need manual allocation with malloc.